Facts, myths, and location about the beautiful Andromeda constellation. There are 16 stars in the Andromeda constellation, which can be seen in the northern sky. In actuality, depending on your location, you can view different constellations in the sky. Various latitudes result in various skies, to put it simply. After the Princess of Andromeda, the constellation of Andromeda is so named. She was a mythical figure in the culture of the ancient Greeks. Of course, as you've surely previously known, the Andromeda constellation is home to the Andromeda Galaxy, which is our own Milky Way's nearest neighboring full-fledged galaxy. In reality, the Milky Way and the Andromeda Galaxy are the two most noticeable galaxies in the so-called local group. The local group is a galaxy group with a massive total mass of the order of thousands of billions of solar masses, and a total diameter of around 3 megaparsecs, or roughly 10 million light-years. The local group is shaped like a dumbbell, and the Milky Way and its satellites on the one hand, and the Andromeda Galaxy and its satellites on the other, provide the lobes. The fact that these two lobes are traveling toward one another at a speed of 123 kilometers per second is arguably the most fascinating and remarkable aspect of them. This implies that they will eventually collide. In instance, the Milky Way and Andromeda Galaxy collision has already begun. There are at least 80 known members of the local group, the majority of which are dwarf galaxies. The actual number of galaxies in the group is unclear because some are obscured by the Milky Way. Why is our constellation so significant? First things first, one of the first constellations to be described was Andromeda. In actuality, 48 constellations were described in the Almagest by the ancient Greek astronomer Claudius Ptolemy. Andromeda was one of them. The Almagest, which discusses statistics, planetary paths, and adopts a geocentric paradigm, can be considered as a mathematical and astronomical book. As a result, it is not only one of the most important scientific works in history but also a crucial resource for learning about ancient Greek astronomy. However, the Greeks, Babylonians, and Egyptians were well aware of these constellations. However, Ptolemy's work was significant since it provided the first recognized description of constellations. One of the largest constellations in the Almagest is Andromeda, which was one of the 40 additional constellations that were added over the years after the original 48 constellations of Ptolemy. Since Ptolemy lived in Egypt for the majority of his life, he was unable to see many of these additions because they are located in the southern sky. Now I want to ask you, how many times have you looked at the stars and attempted to connect the dots, identify a figure, or notice a pattern, but failed? This won't actually happen since I'm about to teach you how to admire Andromeda, so it won't. First of all, you must be in the northern hemisphere for the finest view. This is due to Andromeda moving closer to the horizon as its latitude changes to the south. In other words, it is lower the more south you are. I also have some unfavorable news if you reside at a latitude of roughly 40 degrees south. Andromeda vanishes entirely at those latitudes. Therefore, before beginning your search for Andromeda, take careful to determine your location on Earth. So, once you've chosen the location and are certain that you can see the correct stars, you need to know when. Additionally, everything is based on the time of year. Initially, you should search for it at night because you won't be able to see it during the day. There are some months where your observations will be highly accurate. Generally speaking, the ideal time to watch Andromeda if you live in the northern hemisphere is from August to February. Instead, if you reside in the southern hemisphere, October through December is the finest time of year. In the northern hemisphere, Andromeda appears on the northeastern horizon at 10 p.m. local time from August to September before rising gradually overhead. It appears in the eastern sky around 8 o'clock in the months of October and November. Andromeda rises and glides over the northwesterly horizon at roughly 6 o'clock in the months of December and January. Finding Andromeda is not difficult. Given that you can locate it from one of the most stunning and well-known constellations in the northern hemisphere, it is actually quite simple. We are discussing Cassiopeia. According to Greek mythology, it is named after the conceited queen Cassiopeia, who was the mother of Andromeda and the wife of the king Cepheus. It is a W-shaped constellation, which makes it easily recognized. When Andromeda's mother boasted that she was more attractive than the renownedly attractive Nereid sea nymphs, the sea god Poseidon dispatched Cetus, his sea monster pet, to slay Cepheus' kingdom. Andromeda's sacrifice, according to the gods, may save both the nation and its citizens. In order for the sea monster to easily capture their daughter, the daughter's adoring parents shackled her to a rock by the sea. Fortunately, the charming Prince Perseus rode by on Pegasus, a horse with wings, and fell in love with the lovely Andromeda. They were married and had a wonderful life together. The constellation of Cassiopeia points directly toward Andromeda. You simply need a little imagination to be able to see it. The constellation appears as a sprawling figure with outstretched arms. The figure's feet point in the direction of Cassiopeia and the Perseus constellation. Instead, the head of the figure links the constellation to the adjacent Pegasus square. Now that you're aware of how to find Andromeda in the night sky according on the season and your location on Earth, you can start looking for it. What about this constellation's key characteristics? How can we describe its stars? Do they possess unique qualities, or are they just ordinary, boring stars? We can begin by noting that 3 of the stars in Andromeda are among the top 100 brightest stars in the sky, having brightnesses more than magnitude 3.00. Even while this could be enough to distinguish them, there is actually a lot more to say. Start with the star that is the brightest. It is Alpha Andromeda, also known as Alpheratz. In essence, Alpheratz is Andromeda's head, but it is also a portion of the Pegasus square that it adjoins. This star is 97 light-years away from Earth, and is referred to as a binary star since it is made up of a system of 2 stars orbiting a single mass center. The larger component has a distinct chemical makeup in terms of mercury and manganese, and the 2 components have different masses. In actuality, it is the star with abundant amounts of these 2 substances. Instead, the smaller star orbits the larger star every 97 days and is nearly 10 times as bright as the Sun. Myric, often referred to as Beta Andromeda, is the second brightest star. Stars in the same constellation are typically located at various distances from the Sun. Therefore, it won't surprise you to learn that Beta Andromeda is twice as far away as Alpha Andromeda. It is around 200 light-years away from Earth. It is a huge star that is 3 to 4 times as big and 1,900 times as luminous as the Sun. Myric is the left hip of the chained figure within the Andromeda constellation. Andromeda's foot is represented by the 3rd star, Almach, or Gamma Andromeda. It is a multiple star system with a core giant and 2 white dwarfs in its orbit. The Sun can't compare to the brightness of the core behemoth of the star. The Andromeda constellation has a variety of fascinating objects that can only be seen through telescopes or binoculars, in addition to the visible stars. Binoculars and telescopes can reveal something that our eyes cannot. For instance, as we mentioned, the Andromeda Galaxy, the Milky Way's closest neighbor and nearest full-fledged galaxy, lies concealed someplace in the Andromeda constellation. The galaxy, which is around 2.5 million light-years from Earth, may be found with binoculars even though it is hardly visible to the unaided eye. When using binoculars, search for a misty spot on the edge of the Andromeda constellation to the right of the sprawled figure's right hip, which is just near to Myric. Additionally, the W-shaped Cassiopeia constellation aids us once again by obliquely pointing in the general direction of the galaxy. The Andromeda Galaxy is amazing, because it is now traveling at a pace of roughly 113 kilometers per second toward the Milky Way. You don't need to fear since, sadly, you won't be around when the crash takes place because it will happen 5 billion years from now given its distance from the Milky Way. Don't give up, though, for the collision has in a sense already begun. The collision between our galaxies is already happening, according to fresh research that was published in the peer-reviewed Astrophysical Journal in August 2020. Project Omega, which employs the Hubble Space Telescope to examine the Andromeda Galaxy's surrounds in deep space, provided the information about the galaxy. Absorption map of ionized gas in Andromeda is known as Omega. It was dubbed the most thorough investigation of a galaxy's halo by NASA. The Andromeda Galaxy, the Milky Way, and other galaxies are all surrounded by a vast ring of gas, dust, and stray stars known as a galactic halo. It is difficult to see galaxies' halos since they are quite faint. By examining how much light from background quasars was absorbed by the Andromeda galaxy, these researchers were able to determine the extent of its halo. They were shocked to discover that the halo of the Andromeda galaxy extends well beyond its apparent borders. In fact, it spreads up to 2 million light-years in other directions and as far as 1.3 million light-years, which is the distance of our Milky Way. The problem is that we are still unsure whether the halos of the two galaxies are touching. This is primarily due to the fact that it is difficult for us to measure the properties of our galaxy's halo. Because our view from inside the Milky Way is not the best for learning how our galaxy is constructed, it is much simpler to investigate Andromeda's halo. Consider this: you can easily perceive the shape of an external galaxy when you observe it. However, if you are orbiting within the Milky Way, how do you determine its shape? Much more research and knowledge are required. The Milky Way's halo is thought to be comparable to the two galaxies because of how similar they are to one another in size and appearance. Do you want to know what a merger of the Milky Way and Andromeda would look like? These pictures below were provided by NASA in 2012. They depict what an observer on Earth could see as the Andromeda galaxy hurls itself at us. We can see the evolution of the collision from the present day to 7 billion years ago by moving from the first row left panel to the fourth row on the right. As you can see, the merging galaxies will create a massive elliptical galaxy in 7 billion years that will dominate the night sky, with its luminous core. Here's where the video ends. Thank you everybody for watching.